For the second problem, we have write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated around the horizontal line y equals 7. So looking at our problem here, one of the things that I would do, which we did on the other part, was this bottom one is 2 squared of x. This part is y equals 6. So we want to revolve it around y equals 7. So we need another line here that is y equals 7. One of the things that I would notice is that we have space between our axis of rotation and our functions. The other things that we want to keep in mind is that that means that we're going to be doing the washer method. Our line is above, so we need to be a little bit careful. So our washer method is our volume is equal to pi times the integral from a to b of big R squared minus little r squared. So we need to decide what big R squared is, what little r squared is, and our bounds. Thankfully, our bounds are exactly the same from the last problem. We're looking between 0 and 9 because that is the region R. So our volume is going to be pi, the integral from 0 to 9. We really need to figure out what big R squared and little r squared are. So I'm going to go ahead and do this and add in those parentheses. Okay, so big R squared and little r. So big R is the one that is farther away from that axis of rotation. So our axis of rotation is up here, and if we go all the way down, our farther away is 2 times the square root of x. So now what we need to remind ourselves is that we want the distance between our axis of rotation and the x-axis, and then our axis of rotation, or our value that we want, and the x-axis. So if we only want this much of our graph to be taken into account, we need to take all of our function to the x-axis and take away the part we don't want. So because our axis of rotation is above, we're going to start with 7, and we're going to take away the equation that we have here, so 2 squared of x. Little r is the one that's closer to the axis of rotation, but it's going to still kind of have this same setup. So we have 7 minus that value of 6. I could simplify it. I don't necessarily need to, so I'm going to go ahead and just write those things in. So I have 7 minus 2 squared of x, 7 minus 6. This shows the axis of rotation. It shows the functions that we're dealing with, and so I would leave it just so that we don't have to worry about wondering where things came from. Okay, this is a write but do not evaluate the integral expression, so this is my answer. I don't have to do anything else. One of the things that they're going to do when they grade this problem is they may look for specific things. So there's 2 points for what's inside the integral. So there's 2 points for the stuff inside here. And then there's going to be a point for the constants that we may have to add in here. So pi dx is going to be something we need in the integrand. The bounds are going to be really important here. So overall, this is 3 points, but how they define where those 3 points are, it just depends on the problem in that year. So it may not be the exact same every time, but overall, this is going to be 3 points.